All right, everybody, we're going to be working on the chapter 4 exercises today. And the very first one is the first one that's listed under programming exercises. This one says create a class named form letter writer that includes two overloaded methods named display salutation, right? So two methods, and we're looking at this concept now of overloading. So in other words, we're going to create a method inside of a class structure named display salutation. Then we're going to create another one with the exact same name. And I'll show you how that works when we get there. But the point is, it will be able to dynamically adjust to various levels of parameters that we throw at it. You know, that's really kind of the point of an overloaded method, by the way. Right. The first method will take one string parameter that represents a customer's last name, and it displays the salutation, "Dear Mr. or Mrs., followed by the last name." The second method accepts two string parameters that represent a first and last name, and it displays the greeting, "Dear blank," followed by the first name, a space, and the last name. So see the distinction there, like Mr. and Mrs. or the full name. After each salutation, display the rest of a short business letter, you know, for example, "Thank you for your recent order," yada, 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 right? So we'll come up with some verbiage to do that. Write a main method that tests each overloaded method and save the file as formletterwriter.java. Right. So this is going to involve a little bit of work here, right? And there's a lot of reading into this that you can do. The one thing is, you know, there's kind of an implication here that we're going to create a separate class file. And if you really read it carefully, really what they want us to do is create methods, right? So the focus is once again back on methods and not class and object, right? So I'm going to jump over to Eclipse. I do have Eclipse up and running right now, and I'm inside my previous workspace. So we were working on the previous chapter last time. I'm going to do a close all. So I'm going to go to File, Close All. So it closes all my open files. I'm going to create a brand new Java project. So I'm going to come up here to File, New Java Project. I am going to name this. We are going to be working on the chapter 4 exercises. So that's a fine name, chapter 4. Works good for me. We are at least, this isn't really relevant at this point. When we get to Java 2, this becomes relevant. I did have you install the enterprise level JRE and JDK, by the way. So for the most part, what we're doing in this class, these settings don't matter, but when you get to the second class, they matter a lot, by the way. In fact, some things just won't work unless you select the right ones. Here, we just kind of don't care. All right, so we're going to click Finish. This is going to build out the root of the project. It also creates a folder in my workspace that holds all the assets and resources. And then we're going to go ahead and expand this, right-click the source folder, and create a new class file. I'm hoping you guys are feeling at this point this is kind of routine, right? Because it is, right? But having that workflow. I'm leaving my package declarations blank as I do this because we're not really linking programs together, right? So I leave it blank. We want to call this, as we were instructed, form letter writer. And we are going to add a public static void main. There was a little bit of that in the instructions. The implication was we were going to create a separate class file and then maybe a program to run it. That's not how we're doing it. All right. So do create a public static void main. So here's our beginning of our program. I'm getting rid of the comment marks here. And they want us to create now, well, let's go back to the instructions. You know, I'm a big fan of always referring back to make sure I'm doing the right thing. It says, create a class named form letter writer that includes two overloaded methods named display salutation. So we're going to create two of those, and then it just starts detailing it. So why don't we just go ahead and make the first one? I think that makes a whole lot of sense to me. And so I'm going to go ahead here and, you know, I'm going to use what I would call the standard approach to creating a method inside of a program. So a method can also be referred to as a function inside of Java. And usually we use access modifiers to precede the naming of one. So for example, I'm going to use the keyword public, which means any part of this program or any program externally in the same location can use this method. Static, which implies that, let's think of it on a real simplistic term. Static basically means it can't really change this, right? So it will persist, basically, think of it like that. Void, which is what we call our return type. If we were returning a specific type of data, let's say an integer, it would say integer there. Or if I was returning a string, it would say string there. Void indicates we are returning nothing. The code is just going to do something, but it's not going to return a value to anywhere else in the program. Then we're going to name it. So we're going to say display salutation. And why do we call it that? Because they told us to name it that, basically. And whenever we're creating a method, or if you want to think of it as a function, it's always followed by a set of parentheses. We are going to put stuff inside those parentheses, but first I'm going to do my due diligence here and put in an opening curly bracket, press enter. The closing one is automatically propagated. I do that as a matter of practice. I do it with parentheses and curly brackets and double quotes and a lot of other things. Because if I'm opening and closing something, I don't want to forget to close it and then go, why isn't my program working, right? It's easier to do it now. If you kind of lose track, by the way, you can always like highlight one, right? And notice how the other one's got a little box around it. Hard to see, but it's there. Or if I highlight this one, right? And I'm doing a horrible job of highlighting. That one gets a box around it. There's also these little things here in Eclipse. Other IDEs make them maybe a little more pronounced, but there's these little collapse things that shows you where the code is collapsed to, right? And you can sometimes, trigger that tool to make your stuff easier to look at. But I just want to show you, it also shows you where it begins and ends, and that's kind of my point. All right, so we have the first one is created, and the instruction said it takes one string parameter that represents the customer's last name. Okay, so I'm going to go back here and I'm going to declare a data type. So I'm going to say string inside the parentheses, and then I want to use last name. And I'm going to use the name like this. So I'm going to use camel case and just say last name. That works for me. All right. Okay, so it takes one string parameter that represents the customer's last name, and it displays the salutation. So let's write the system out print line, right? Mr. or Mrs. followed by the last name, right? Okay, that seems pretty simple, right? So let's go ahead and get to writing a system out print line. So we're going to do system dot out dot print line parentheses double quotes and our message, and we're going to say, dear Mr. and Miss. I'm going to do Miss, okay, whatever. Space, and then we'll concatenate to that the last name that was typed, right? Dear Mr. and Mrs. Smith, for example. Right. Let's put a semicolon at the end. All right. So there's the one, right? Let's read the next instruction, right? The second method, and keep in mind, we're going to use the same name on it, which is kind of weird, accepts two string parameters that represent a first and last name and with a different greeting. All right, let's go back over. And you know what? I'm smart enough to know that if it's got the same name, can I just copy the whole thing? Sure, you can copy the whole darn thing, which is what I'm going to do. And then right below it, I'm going to give myself just a little space. I'm going to paste it back in. And now it doesn't like it because right now we have something already named that. So if I hover over the error, it says duplicate method display type form, blah, 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 blah. One quick fix it, rename it. Okay, well, I don't want to do that because I was told to name two of them the same thing. Right? But there is a difference, and that is we're going to add another parameter here. So I'm going to add another one called first name and a comma, and I want them in that order. So we'll send first name first, last name last. There's two things we're sending in. So these, parameters that we're sending here will need to be received in this order, and they need to be of these data types. All right. Now, the output on this one is a little different. So it should say dear, followed by a first name, a space, and a last name. Right, see the difference? Right, so we're going to do dear, and then we'll concatenate first name, and then we'll add a space, and then last name. And you know what? I didn't think about this up here. When you write a letter, you're supposed to put punctuation at the end too. So I would, like, for example, I'd either do a comma or a colon. I would probably do a comma, right? But we're going to do the same thing here. So we'll concatenate comma. Now notice when I added the second parameter, and now they have, this one's got the same exact name, but only takes one parameter. This one's got the same exact name, but takes two. That's allowed because they're receiving different amounts of information. So in other words, if I send call display salutation as a function, and I just send it one name, right, it will use this one. If I send it two pieces of string, whatever, it'll use this one because this one can take it. And if I wanted, right, I could set up another version that takes three pieces of information or five pieces of information with the same name, and provided I'm sending the right amount of information, the engine in Java will automatically pick the one that can take the one that you're sending, right? And so this is what we call overloading. So we're overloading a method. We have one way to do it. Well, we're going to overload it. We're going to give it more parameters. So here's the second way to do it. But it could be more. Right? We're just doing two. All right, let's go back and read the next set of instructions here. So as far as I can see it, we completed everything up until here. It says, after each salutation, display the rest of a short business letter. For example, thank you for your order, yada, yada, yada. Okay, so here's what I'm going to do is I'm going to create another method that's going to handle the generic business letter part of it, right? And so just follow with me here on this. And what I'm going to do is I'm going to do it in kind of a weird fashion, is because I could type up the letter here, right, in this spot, right? And then, well, this one would need the same letter, so it would be silly for both of them to repeat the same code. And the whole point of these methods, by the way, is to avoid repeating writing of code, right? So if both of them, regardless of the salutation, want to send a message, and let's just say the message is really, thanks for your order, right, is really kind of what it is. Why don't we create another method that just handles the generic business letter part of it, just puts it on the screen? So I'm going to do it backwards. I'm going to create the name for it. So I'm going to say order thanks is what I'm going to call mine. Set a parentheses and a semicolon. Now, this doesn't exist, so it underlines red, right? And we saw this in Eclipse before. This is one way to create a method, is just name it and call it, and then it won't find it, and then it'll give you a quick fix that is create method called order things. So you know what? Let's do it. There it is. So there's the order things. I don't really want it sitting right here, so I'm going to cut it because I want these two overloaded methods to stay together. So I'm just going to move it down here to the bottom. You'll also notice that by default, Eclipse sets the method to private. And you know what? I'm going to leave it that way. And so in other words, if somebody called just this method external to this program, they wouldn't be able to do the order things because it's set to private. However, something inside the program like this method could call order thanks because they're inside the same program. And this private, well, it's everything that's inside this class that's private. So this method can access this one. And let's think about it. Maybe externally, I would want to run this one, but I would never want to run this one without the salutation, right? So, all right. So that's a quick, easy way to create one, by the way. Notice private, only accessible internal to the program. Static, it's not going to change. It's going to stay the same. And void, it's not returning anything. This is just going to put stuff on the screen. All right. Okay, what about the stuff we're going to put on the screen? Now, I'm going to leave that up to you. The example that we were given was really basic. It was like, thank you for your order. Please come again. You know, that kind of thing. I took mine a little bit further because I wanted it to look nice, of course, right? So you can take this with a grain of salt. You don't have to type all this in. Yours could really just say, thank you for your order. Have a nice day. That would be fine by me. But I took it a little farther, right? So this is what I did. I did all of these system out print lines, including blank lines. And I know I could do them with escape sequences, but this just looked better to me as I was reading it. And you say, thank you for your recent order. We hope you enjoyed the stuff you bought. You overpaid for that junk, but it's too late to return it. Now, whatever. Okay, so you can see I'm like totally joking. Sincerely, Amazon.com, or, you know, whatever. You know, and let's not like pick on a company too much. Let's call it whatever.com. And then I put like little ASCII art at the bottom, right? So in other words, dear Mr. and Mrs. Smith, comma, and then all this stuff would pop up on the screen, right? Or it'll say, dear Joe space Smith, comma, here's your stuff, right? All right, so now all that we have left to do to make this work is to call these two functions, and we'll do that in the main method. So I'm gonna call display salutation, and we'll send it one piece of information. We'll just make it a last name. And, you know, I was using Smith as an example, so I'm just going to stick with that. So this one, we're sending one string, right? Where's that going to go? With one parameter, it's going to find this one. Okay. Then we'll repeat the call. And then for the second one, we'll do first name, and then last name in that order. So we're going to send both pieces of information. So when I send it, I'm sending those two pieces of information. It'll look here and go, oh, nope, doesn't fit. It'll look here and go, yep, it fits. Let's use this one, right? And if we had one that took 3 or 4 or 5, we had different versions, it would find the right one and use that one. So the second one will find this method, and it'll say, dear space John space Smith, comma, and then the whole letter, right? But the whole letter won't call unless I do order thanks and add it here. So this is kind of another aspect of this, right? If I ask it to display a salutation with a piece of information, it does it, and we only have the last name, so it does it this way and then puts up the message, right? This one method that we're calling is calling another method, right? And you can do that, right? So one method can call another. How far can you take that? As far as your brain can comprehend it, right? It'll work, right? There's a limitation to that. If you want to think about this from a data processing standpoint, that like, wow, is this how they do form letters? Well, not exactly. There were times where we did do form letters this way, but you can imagine that like the data that we're dropping in here, whether it's a last name or a first name, last name, could be information that we read in from a database or an external file, and then merge that into a form letter. Yeah, that could totally be a thing, right? All right, so let's try running this. All right, so first of all, here's all the code for the screenshotters, right? So if you want to try to grab all of it, there it is. And we'll hit the run button on this. Let's hit save first, though. We'll hit the run. There's no, by the way, there's no prompting here, right? So we're just going to see 2 form letters. So here's the first one, dear Mr. and Mrs. Smith, and all the stuff I typed, and then I put in a divider. Now you can see why I did the divider, right? Then the second letter, dear John Smith, first and last name, and then the same form letter. So that would be an indicator of it working correctly. All right. Now, let me take a moment here to just very quickly pause the video. Okay, folks, we're going to move on to the next one. So I'm going to flip back over and see which one we have to do. We go all the way back to the course here. And next exercise is exercise 2. And so that one reads like this. Create a class named billing that includes 3 overloaded compute bill methods. So once again, we're overloading methods. And then when compute bill receives a single parameter, it tells us what to do, represents the price of one photo book ordered, add 8% tax, and return the total. When it receives 2 parameters, it will be the price of a photo and the quantity ordered, multiply the 2 values, add tax, return the total. It's a little different. And the third one is when it gets 3 parameters, and then you get the price, the quantity, and a coupon value, or a discount, basically, right? You multiply the quantity by the price, reduce by the coupon value, and then add 8% tax and return the total, right? So 1 parameter, 2 parameters, 3 parameters. So this is practicing our overloading, right? Then we're going to write a main method that tests all 3 overloaded methods. So the same way we just did form letter writer, it's all going to be in one program, and it's going to have a public static void main. That's really what they're telling us. We are going to call this billing. All right. Back over to Eclipse. All right, so here in my chapter 4 project, I'm going to right click that source folder, choose new class, and we're going to call this billing. So B-I-L-L-I-N-G. We are going to create a public static void main, no package declaration, and we're clicking finish. All right. Blowing away the default comment here and getting ready to write code. So we are told once again, in very much the same way, that we are going to create 3 methods that basically do the same thing, right, in various degrees. So I'm going to do the same pattern I did before. And I'm going to manually create the first one. I'm going to do public static. And hold on a second. Do I do void here? No, we're not going to. This is one of these examples where we're not doing void, by the way, because it says at the end of each one of these, return the total due. Return the total due. Like, so you see that, right? So we're going to add to our method a return statement at the bottom that's going to return a value, because what we're returning is a financial amount. Most typically, we'll do that in the form of a double, right? That's the most typical data type for monetary formats. So, so that keyword double refers to the fact we're returning a value of type double. Now we're going to name it. We're going to say compute bill, parentheses, and curly brackets. We were told that the first one needs to have at least one value that it accepts, and according to the instructions, it'll give a single parameter that is the price of the photo book ordered. All right, so let's do that. Let's go back over here and let's tell it what data type it's receiving, which is a double, and they called it price. Well, let's call it price. So there it is, double price. In years past, I have called it different things, so don't switch between videos is my advice. All right. Inside here, we're going to do the creation of a variable, and then I'm going to tell you why that this might not be the best way to do it. Right. So first, I'm going to create a variable, and I'm calling it bill, and what I'm thinking is this is the total amount we're going to bill the customer. And they told us back in the instructions, right, It represents the price of one photo book ordered, add 8% tax, and return the total due. All right, so now we got to talk about how to calculate that. So if I walk into a store, imagine the scenario, and I want to buy a candy bar, and it costs $1, right? They're going to charge us sales tax on it. And how do you determine, so how do you determine what your total price is? Well, okay, so here's what I'm going to do. I'm going to pull up a calculator. And so, for example, I walk up and here's a candy bar, $1, right? Then they're going to multiply it by the tax, right? And so let's say the tax, we're just going to use 5% as the example. So I'm multiplying by 0.05 for 5%. So the tax is 5 cents. Is that what I pay? 5 cents? No, I got to pay $1.05. So I got to take the amount, right? Multiply it by the tax to get the tax, and then add that to the amount, right? So in other words, I will take the price, multiply it by, well, okay, we're going to have a tax rate here. We don't even know what the tax rate is. Well, we were told what the tax rate was. So here's another piece of information, right? 8% is the tax, right? So back in Eclipse, once again, way up at the top, and I'm doing this above the main method, right? And outside of any of the other methods, but inside the class file, I'm going to create a constant. So we'll use keyword final. We're going to make it static so it can't change, basically. It's going to be a double because it's for finances. We're going to name it all caps because that's a convention for naming constants. And then we're going to give it a value of 0.08, so 8%, right? And we're hard coding that. It's a constant, can't change, right? So here, instead of multiplying against 0.8, I could have done that, right? But it's better to do it this way. And then we'll add the tax calculation back to the price of the original item, right? So this is the complete calculation. Now, why would we do this? So like if I'm writing a program and I refer to the tax rate, let's say 50 times in the program, and then it's like, oh, hey, guess what? Tax went up, or tax went down, got to change it. Would you want to go in here and find all the spots where you typed in 0.08 and fix it? And then what if for some reason there was a 0.08 that wasn't related to the tax? It was some other 0.08, right? So by using a constant like this, if I ever want to update my program, all I have to do is change this, right? And then all the other ones will fix, right? So that's the why. So that's the initial calculation. We're storing it in a variable called bill, and then we will return the value that we stored, which is in the form of a double. Now you see the red underline go away, right? So there you go, folks. That's the first one, right? But now they want us to create 2 more versions. So here we copy all this, and then we're just going to ramp it up. So we're going to call it the same thing, but for the second version, we're going to get the price and the quantity ordered. All right, so here we go. The price is already there, so I'm just going to add a comma, and then quantity sounds like an integer counting number, so I'm going to call it an int, and let's just call it, how about QTY for quantity? All right, now we need to add that to the mix, right? So we might think of some really clever names here, and you know what, I struggle with what to name things sometimes, and I'm looking at my previous examples and not necessarily agreeing with how I did things. And maybe really a better word for bill is the subtotal, right? Is really what we're calculating. And is the calculation here correct for tax? No. Okay. So first, think about this. If somebody's ordering a book, they pay the price of the book. If they're ordering 2 books, then we have to multiply that first, right? So I'm actually going to remove all of this. I'm not going to delete it. I'm going to cut it with Control X. And now in here, I'm just going to multiply the price times quantity, right? So we get like a subtotal for the amount of books that we're purchasing, right? So now we have that value is captured. Then we can take that subtotal and we can add to it the cost of what? The tax, right? So a couple different ways we can do this. So one would be the way we did it above, where I take the subtotal, we just basically copy that formula, times the tax plus add the subtotal back to it, right? But I'm not going to do that. What I'm going to do instead is I'm going to plus equals, because that includes the subtotal in it. You guys see that shortcut too? So that's an approach there as well, to save you a little bit of code. And then we need to return basically that subtotal. And right now we're returning bill, which isn't the right thing because it doesn't exist. So we are going to return the subtotal back to the main program. So that's the second method. Right. Now I'm going to copy the second one and I'm going to paste it again. And this time we have to have three parameters. So it'll be the price, the quantity, and the coupon value. All right. Let's get that in place. So we got price, we got quantity, and then we have one. And what do we call this one? I guess we'll just call it coupon, right? I'm going to also make this a double because we're once again dealing with money. So we're double coupon. And then we have to do some math. Now, can we use some of the same math? Are we still going to multiply the number of books times the quantity? Yeah, we have to do that either way, right? All right, so then that's in our subtotal. What we're going to have to add that we didn't have before is the coupon amount. And so we'll say the subtotal would be equal to the subtotal minus the coupon. Or if you want to like be a clever programmer, which I hope you are, wanting to be, you can also minus equals the coupon amount. And so like the coupon is probably be like, oh, $5 off or something like that, right? Not a percentage, but like a straight dollar amount. That's how I'm envisioning it, right? So we're going to subtract that coupon from the subtotal. Then we're going to add to the subtotal the tax, and then we'll return the subtotal. So here we are with one parameter, two parameters, three parameters, and the math adjusts accordingly, you know, all the way through. The only thing I guess I'm not really kind of liking a lot right now is how I named this. So I'm going to call this one subtotal 2, just to make myself feel better. Now let's reduce by the coupon value, then add the tax. Okay, we did that. All right, write a main method that tests all three overloaded methods, save the application as billing.java. Okay. So let's go ahead and go back to the main method now and call all of these to get them to run. All right. So inside here, you know, when we're going to call one of these, we're going to pull back an amount, right? And whatever amount it is that we pull back, that's going to be our total for our customer. And you know what? I think total is a good name for it. So I'm going to create a variable to hold it. So I'm going to create a double called total. And then to populate it the first time, I'm going to call compute bill with a single parameter being sent, which is going to be $10. Like so, right? This will call the function, send it the value. The function will return a value here. Then remember, whatever's on the right side of the equal sign gets stored in the thing on the left. So it'll store in total. So then all we have to do is put it on the screen, right? And so what I'm going to do here is just to make it really clear what we're doing is I'm going to do a system out print line. So get that part in place first. With my parentheses. And then the message inside is going to say something. And I'm going to make a little note. This is for me, right? And normally you wouldn't show this to a user, but I'm just going to put a little number in front of it so I know how many parameters. In fact, if you want to do it like this, I'll say one parameter, you know. the output for that would be your total is space, and then we will concatenate to that whatever the total is. That's just going to be put in there. All right. Now we're going to do this again, right? But this time we're going to say, we're going to use the same variable to hold the result, because we just put the result on the screen for the first one. Now total could be reused again. And so we're going to use compute bill, but this time send it two pieces of information, $10 for the cost of the book, and we're buying 5 books. Okay. How do we know that that's what it is? Because we look down here. First comes price. We only do 2 things. Second comes quantity. One's a double, one's an integer. So I'm making sure I send them in the correct format too. Okay. Semicolon. And then we'll do another output. So we'll just borrow here this one, and I'm just labeling it for my own sake, right? So I know which one is operating. It's the 2-parameter version, the 1-parameter version. And then, as you can imagine, we just repeat this again to try the 3rd level of it. So we'll just paste that in. Now we're going to have to send in 3 parameters. Right, so we'll type a 3. Oops. Right, my cursor really jumped there. There's my 3. And then here we need to send in an additional value with the coupon amount being a fixed dollar amount. Now I'm thinking a coupon of maybe, I don't know, $5 seems like a good coupon. Right, so $5. That will be price, quantity, and coupon in that order. So price, quantity, and coupon. Keep in mind, you can't change the order you're feeding it in. You got to send it in the order that it's expecting it. So make sure you're doing that. The other aspect of this is like right now we're hard coding values, but what if like you were actually running a cash register program, right? And the data was coming from that, or a scanner, or whatever. You can imagine all the different scenarios. All right, so we have the 1, 2, and 3 parameter version, right? So let's run this and see what happens. So I'm doing a Control S to save, and here comes the run. And of course, this just does it, right? It doesn't prompt us for anything. And it says for the first one, $10.80. Is that right? So we could use a $sign here, I suppose, or we could use a 2-digit formatting. So you can do all the formatting stuff that we talked about if you wish. I'm more worried about getting it to work, right? The second one, we bought 5 $10 books and then added tasks. So 5 times 10 is 50 times 0.8, yeah, $4 tax. That's correct. If we do the last one, we buy the same number of books and there's a $5 coupon, right? Is that the correct amount? Some of you might say, no, it should be $5 less. Well, no, because the tax is calculated after the discount, right? You don't want to pay the tax and then get discounted on it. You want to get the discount and then pay the tax, because then the tax is less. So that would be correct as well. Another kind of thing to think about here is this concept now that we're using this variable over and over again, and that's fine. It is possible as well, if you wanted to go right to output, not store the value, right? Because right now we're running the function, storing the value, and then outputting it. You could also do something like this. And this one I'm just pasting in, by the way. You could just put in a system out print line and call the function right from the print line, sending it a value, and that will also work. The advantage to this approach, if you care, right, is that you're not storing the value, so you have a more rapidly executing program. It's not reading and writing to memory. It's just getting the value and putting it on the screen, and that's a difference. If you plan on using that value later for something, then you want to store it. If you're not, if you're just putting stuff on screen, you can skip it, right? And those are judgment calls that programmers make. depending on how the program operates, right? We can do a control S to say, let's just run it one more time. So even with the alteration, you can see that it still works correctly, although I have like extra punctuation in there, whatever, right? That's easy enough to fix, right? I don't know where that came from. Right? But like, once again, I did this really for my own sake of knowing which one is hitting the function and how it's coming back. And that's just helpful for me. So that part, in other words, this part doesn't need to be there. For me, it just shows that how many parameters we're sending and that one's working the way we're expecting. All right, so there's our completed program, folks. This is billing Java. This is exercise number 2. What I would like to do is I would like to take a quick, like 4 or 5 minute break. It is currently 8:58, so we'll come back at like 9:03, 9:04, or something like that, and we'll work on the subsequent exercises. So the recording is being paused. All right, well, welcome back from your break. We just finished this exercise here, the billing exercise. While we were on break, I was struggling a little bit to define the concept of static. And so what I did is, of course, I Googled it, right? Like all good individuals should do. And so let's just look at this little explanation here. The static keyword in Java indicates that a particular member is not an instance, like an instance of a class, but rather part of a type. The static member will be shared among all instances of the class, so we will only create one instance. So when I create a method that is static, what I'm saying is that this is not going to be replicated, right? Where in a class file, if I have a method, I may allow it to be replicated or I may not, right? There's other implications here as well. So if you want to do the same search design, you can see I have my generative AI renderer here or whatever. But they get into talking about static variables versus static methods and what that means, and they give examples and the whole bit. So if you want to read up, hey, feel free. Our book talks about it too, but sometimes it's not a bad idea to look at outside stuff. I wouldn't call this a really critical concept at this point to really wrap your head around. It has a lot to do with how things are created inside of Java, but when you do get to higher levels, understanding its meaning is really helpful. Is a good way to say it. All right. Let's go ahead and get back to coding here. So I'm going to jump back over to our core shell and first look at what is our next exercise. It is exercise number 4. Let's read about that one here. So right here. And notice it says 2 parts here. We got a part A and a part B. And it says create a class named blood data that includes fields that hold a blood type. The 4 blood types are O, A, B, and AB. And there's an RH factor, which makes it positive or negative. So all of those have a positive or negative designation. So it could be like O positive or O negative or A positive, etc. Create a default constructor that sets all the fields to type O and positive, and an overloaded constructor that requires values for both fields. Include get and set methods for each field. Save this file as blooddata.java. Then create an application named testblooddata that demonstrates that everything works, and then save it. Okay, so create 2 programs for each portion of this, right? So let's start with the first file. So we're going to create this is going to be our blueprint file, if you want to think of it that way, called blood data. That's where we're going to start. All right, so let's go through the mechanics of this. The instructions are pretty clear. So if you follow the instructions carefully, you should be okay, right? And that's really the kind of nice thing about using a textbook like this, is that guidance that you get. Right. So here in my source folder, I am going to right click again and create a new class file. And this one's going to be called blood data. So blood data. This will be non-executing. So we do not need the public static void main. and no package declaration here. We're just going to go ahead and click finish. All right, so there's our public class name blood data. They did ask us in the instructions that to include fields, and these would be data properties basically that hold a blood type and an RH factor. So I'm hearing two things here, right? So that's the part I'm working on right now. So here inside here, I'm going to create these data fields. Now these data fields are private. So in other words, they can only be changed by stuff inside the object, not from an external force directly. That's why we're setting it to private. We are going to create a string, because you think about this, O, A, B, and AB are all letters, right? And then plus or minus technically are characters. So all the stuff we're going to create here is strings, right? So we'll call one blood type, like so, not presetting a value here. And then we're going to create the other data field, if you wish, also a string, and this one will be called RH factor. That holds the plus or the minus. So that's our two data fields unused so far, right? So let's read the next instruction. That's probably a good place to be. Okay, so they talk about all this stuff. We create a default constructor and an overloaded constructor, include get and set methods for each field. All right, how about we do this first? The get and set, we learned this cool trick last week, right? How to do gets and sets really quickly. Let's get that one out of the way. That seems like a really easy thing to do. So if you remember, I'm inside my code, the files. I have my data fields are defined. And then what I'm doing is I'm just going to right click. I'm trying to remember, is it source? It's under the source menu on the right click. We're going to generate getters and setters. It will read our two data fields, and you can see that it did that. And I want them for both. And it said to create getters and setters for all of our fields. There's two fields, so I'm going to do it. But remember, you can look inside here and you can selectively choose these. We're going to set all these to public, so meaning that after the object is created, an external force could come in and change these values, right? But it wouldn't change the private fields directly. The public methods inside the class would change the private fields, if that makes sense. So we'll click OK. And there's all of our getters and setters. And one of the reasons I like to do those first is, you know, those are kind of mechanical processes. And I just push them to the bottom, right? And so for each one of the fields that we have, so for example, just to kind of review this, for the string of blood type, we have a get blood type, which just sends back what is it currently set to, right? That just returns it. The other one is a set blood type, which receives the value and applies it. So it takes this value that it receives, puts it here, and then that gets stored here internally in the internal object data field designated by this. What is this? This one, the one that we're currently working on. So it's self-referencing. The correlation to Python, of course, if you guys are using that as a correlation, the keyword we used there was self, right? And then the same thing happens for RH factor, exactly the same way. So there are those. Now it's asking us to create a constructor, which has to be public, by the way. And a constructor is always named the same as the class, and it is a method, and we'll give it curly brackets. All right. What they told us to do is to basically set the blood type by default to be equal to type O, if you remember from the instructions, and the RH factor to be set to positive. And note, you know, the plus sign is a character, so it's inside of quotes. So that's what they want us to do. So if I just instantiate a new blood data object, it will automatically be type O positive. Right? And we can test that. Now, interestingly, and I'm just going to have you think about this, this is one way to do it, right? And this is fine. This will work just fine. There's no problems with it in any way, shape, or form. But you might want to consider an alternate approach. And it goes, once again, to this concept. All right, I'm going to comment these out. I'm just going to put a couple double slashes in front of each line so they're not active, but I'll leave them there so you can see them. There's another way to do it, and this would be, this is really clever. I think it's clever. Is we're going to call this and send the information that's default and pass it to itself to receive two parameters. You know what? I'm going too far too fast. Let me control Z this. I'm going to come back to this. I'm not ready for it yet. I'm just realizing. All right. The second directive was to create another constructor function. Okay, so it's going to have the same name, same parentheses, same curly brackets, but this one will accept two pieces of information, right? So one would be a string that would accept the blood type, and I'm just going to call it B type. I mean, if you want to call it blood type, you can. I'm just making it shorter, B type for blood type. And then another string, and I'm going to shorten this one too and just say RH. So it's going to receive that information externally, and then we can take that information and kind of like we did here. So why don't I just do this? I'll copy these two signs, and we're not going to hard code a value, but we're going to feed in the B type, right? And the RH. And then we'll just get assigned to the correct one, right? So with no parameters, it will do this automatically. With two parameters, it will take what you send it and apply it, right? So now I'm going to go back to my clever little hot wiring here, which is to comment these two out. And then instead of directly assigning these values, and you might latch onto this and you may not, so don't feel bad if you don't. I could do this, right? Which means that I'm calling itself. I'm not giving it a name, but if I'm calling itself, that means I'm calling a blood data object, whatever it happens to be called, and it will run the default constructor, which is this one, but this one's got no parameters. But if I wanted to set it to O and negative, I could put those values here, right? So type O or positive to O positive is what we're doing. And then it all of a sudden has two parameters. So it finds this one, sends the values here and sets them here. So you might call the default constructor, which then calls the two value constructor to actually do the work, right? So this is a clever, I'm going to call this a clever alternate approach, right? Calls the two parameter constructor. Okay, so I'm just putting the notes in there so you have them. All right, that is our blueprint, folks. So let me kind of zoom out here. Here's all the code for the whole thing, right? So that's the complete class file. Remember, non-executing, two data fields, a no argument constructor and a two argument constructor, getters and setters for everything. The no argument constructor ends up self-referring and calling the two argument constructor to set its values, or you could use this approach, the more basic approach. Either one is fine. Right. Let's save this. I'm doing a Control S. Now we need to create a program that's going to test this. Okay, so once again, back over to the source folder, right click, new class file. All right, we're going to call this test blood data. Why? Because they told us to call it that. We do want a public static void main, so it executes, and then we're just going to go ahead and click finish. All right, so here we have a program ready to go. And basically what we need to do here, let's read the instructions, I guess, is, okay, create an application named test blood data, demonstrate each method works correctly and save it. Okay, all right, so that's what we're doing. All right, so I'm going to go ahead now and I'm going to create a new object. So in memory, I'm going to call the class structure that we just created, the blueprint blood data. And I don't know what to call this. I'm just going to call it B1 for blood one, whatever. And that will be a new blood data object. The first one will be with the blank constructor. So the blank constructor will go back to the class file, find the blank constructor here, and execute the code inside. Unbeknownst to the users, of course, the blank constructor is calling the 2-argument constructor and then setting the values. Or you could do it the old-fashioned way once again. So that's what that one would do. Right. So B1 would be type O positive. Right. Then we'll create another blood data object. We'll call this one, I don't know, something clever like B2. Right. Also using the new keyword to create the object in memory. And this time inside the parentheses, we are going to send values, and we're going to send in A for the blood type and minus for the RH factor, and then a semicolon at the end. Right. So now we want to show what's in these objects, and you know what? No matter how many of these create, the process for showing what's inside is the same. So what I'm going to actually do is I'm going to create a method called display, both to get practice making methods and also to cut down on the amount of code I'm writing. And I just created the name of it first, and then I'm going to let the automatic tool here in Eclipse create the method. Can it be private, public? It doesn't really matter, real frankly. I'm not too worried about it. I'm just going to leave it private. But inside here, what we're going to send to display is one of these blood data objects. When we list the data type here that we're sending, it's not like a string or an int or a double or something. It's actually a class, right? It's blood data. What kind of thing are we sending? A blood data object, right? So we tell it what kind of thing we're expecting. I'm just going to call it B, right? The thing that we're sending. Then we just need to put the stuff on the screen. And here's a generic statement that will do that, right? Just the system out print line. We're going to say the blood type is, we're going to take whatever thing is sent in. We're going to read into the object, into the method that says get blood type, right? And get the RH factor and put them on the screen. So A positive, O negative, whatever, right? And that's all the work that this does. That just puts the stuff on the screen generically, right? So if I'm going to run the display method, I need to send in the object. So I'm going to display what? B1 is what I'm going to display. And you know what? I created a B2 also. So I'm also going to display B2. Like so. Right. All right. We can already run this. And in fact, it's not a bad idea to test it. So let's just go ahead, make sure this is saved. Let's hit that run button and see if it displays. All right. So the first one, right? The default constructor, O positive. The second one where we set it, A negative. So far, so good. This stuff is all working. We're creating the objects. We're setting the values as we decided, but we did test the gets, right? The one thing that we didn't test was the sets, right? So what we can do, for example, and you can ramp this up as far as you want. I'm doing really simplistic examples, but you can take it much further to test it. I'm going to just take one of these objects, B1, the one that we didn't set the values for, and I'm going to call set blood type setter. And then I'm going to indicate what the new blood type is, and I'm going to go with AB, and that's a blood type. Right, so we're going to set the blood type of B1 now to AB. And then on that same object, B1, we're now going to set the RH factor with, potentially a new value, which is negative, and it was positive before, right? So the RH, so it switches from type O positive to AB negative. And you know what? Let's prove that it worked. And then we'll just do a display again, call it B1, right? Or throw in B1, and then we'll see if it worked. So let's run this, save it. Yep, there you go. So then right here, you can see that B1 did change from type O negative, right? The first thing that we ran, to after the sets to AB negative, right? So we are showing that all the capacities of this work. If you really wanted to do exhaustive testing, I would probably create a few more blood data objects, display them all, then do sets and gets on all of them, change everything around and display it again to make sure it's all working. This is a test program, but what we've done here is very powerful because these are the types of things that we do in high level programs, and we don't even think about how we're dealing with the objects and stuff. But the idea here is basically that we can create these complex structures, right, that contain multiple pieces of information, multiple variables or constants or whatever, that have a way to build them and set the values, and then have a way to change the values inside. And then, of course, you can ramp it up further and build in all sorts of other capabilities. Like, for example, the ability to, and this actually is a really good ramp up, the ability to actually display this information. When I think about it, well, that could be built into the object too. So let me show you what I mean by that. So let's do this. Let's comment this out, and I'm just gonna, if you can ride with me on this to kind of see the concept. We're gonna comment that out. And I realize this is underlining red, but we're gonna come back and fix that. But the system out print line here, and really, actually, all right, let's get down to it. This whole method, I'm going to copy this whole method. I'm going to move it over to the class, and I'm going to add that here under the constructor. Yeah, I realize I have comments that I'm going to ace, so I'm going to get rid of those. Can I leave it just the way it is? So public void display. We still are expecting to receive a blood data object here, or do we need to do that? And here's the answer. We don't need to send it anything, because now we're inside the object. You see the difference? And then here, instead of calling in an object that we're passing, we're going to say this dot get blood type. And you see, it doesn't even like that. So I think we can just simplify it to get blood type and have it return the blood type. The problem that it's having, right, is, all right, let's get this out of here, right, to eliminate all the sources of errors. Now, what is it saying is an error? Change get blood type to static. Okay, this is kind of an interesting thing. So it's saying that this method that I created here, which is going to return the blood type, do I need to do it this way? If I'm internal to the object, do I need to call the method? No, because here's the answer. We don't need to do that because we're already inside the object. Once again, all I have to do is pull up blood type, right? It's already here, right? I don't need to get it. It's going to just pull it directly from here. And here, I can do RH factor. Now, these are both underlining again, and let's read the message, right? Change blood type to static, and they just don't like us using that approach, basically. So let's see if this would actually execute. It sure doesn't like it, but if I change this up here, add the keyword static in front of it, that seems to fix it. Let's see if that makes it run. We have some modifications to make here, though, because here, instead of displaying B1, we would operate it a different way. The way that we would operate it is we would say B1 dot display parens, right? So it's going to reach into the object and just run it. Is that what we called it? Display? display. Oh, and why is it underlining red? Because it's set to private. So that needs to be set to public. That should fix the one underline. There it goes away. And then this one will change to, and now we'll say B2 dot display parens and a semicolon. And then down here at the bottom, we're just going to repeat B1. And you see kind of the difference here, folks, in the approach, right? That the display function is now removed from here. It's built into the object itself, and we're just calling it, and it just works. Right? Okay. Let's go ahead and save everything. Do save all. We'll go back to test blood data and make sure it runs correctly, with the same kind of output, and you can see that it does. Now, from a modern programming standpoint, I would prefer that you did this kind of an approach, because the capability to show the data of an object itself being built into the object makes a whole lot of sense, right? And that way I don't have to write extra code in my program. Once again, even though this is fairly efficient, it's better if it's built in. It really is, right? We do have some messages here. Static method display from the type blood data should be accessed in a static way. All right, yeah, whatever. All right. Not really a big deal. But here's where we get into like nuances of all this, right? But this approach is really a good approach. Right? Did you guys all get this to work okay?
No.
Okay, not surprising. Here again. All right, we have one more to do, and that is exercise 5. And exercise 5, also a two-parter. And so we have an A and a B here, and it says create a class to hold data about a high school sports team. The team class holds data fields for high school name, sport, and team name. Include a constructor that takes parameters for each field, and include get methods that return the values of the fields. Notice it says nothing about set. Okay. Also include a public static final string named motto and initialize it to sportsmanship. Write an application named test team to instantiate 3 team objects with different values, and then display all the data, including the motto for each object, and then save both the team.java and test team.java files. All right. So a few different kind of things to happen here. And folks, as you kind of like work on, doing this type of thing, and when you look at like complex instruction sets like the ones that we're looking at, it is very helpful, by the way, to read the stuff really systematically and very, very carefully, in terms of how you're putting it together. So let's start with the team file and see if we're reading the instructions as carefully as we should, right? We'll start by creating a new file. So we have new class file. This is going to be called team. This is our blueprint, so we don't need a public static void main. Package declaration is blank. All right, so there's the class file. Inside here, we're going to have a few different things to access or create data fields. And we'll start with first a string for the name of the team. Another one for the sport we're playing, basketball, football, baseball, whatever. Another private string that will be our mascot. Maybe it's the tiger or whatever. Taylor Swift, I don't know. that was bad, sorry. And then we also want to create one, and I think they got kind of like particular about how they said this. And also include a public final static string. They tell you right there. You know what? So I better make it exactly that. A public static or public final static string. spelled correctly. And we're going to call that one motto. Why all uppercase? Because this is a constant. Right? I don't know why, but you know, they're doing this, but hey, whatever. Sportsmanship. And they want an exclamation point in there, and then we'll put a semicolon at the end. All right, so there it is. Those are our data fields. You know, 3 privates, 1 public. We did that one that way because that's what they wanted. So that's what we're doing. We are going to create our constructor. So here comes the constructor. It's call it after the team. Parens inside here, we're going to create a string. So it's going to receive the name. We're going to create another string that receives the sport. We're going to create another string that receives the mascot. All right, we've got our curlies. And then we're going to take all the stuff that we just sent in and apply it to the object, data fields. We'll use the keyword this. So we'll just say this dot name equals name. This dot sport equals sport. And this dot mascot equals mascot. So, right, so we're coming in, putting them here, attaching them to the object. Right. They also asked us to create getters, not setters, just getters for all 3 of these data fields. So I'm going to use my tool again to do this, and I'm just going to right click, once again, source, getters and setters. What are we going to set? Well, we're not going to do motto because that's final. You can't really do anything with it anyhow. So we're going to do mascot, name, and sport, but we're only going to choose the get option. Just going to return the value. We'll use public as our access modifier, and that's it. And so click that, and then you have this. So here is the completed team file, class file. This is the whole thing. All right, I'm going to do Control S to save. Next instruction is write an application test team to instantiate 3 objects with different values and then display all the data, including the motto, for each object. All right, so now we're going to do our test team. All right, back over to Eclipse. And good news is we should be able to finish this here tonight. Sometimes when I do this, I run out of time, real frankly. All right, so we're going to call this test team, no package declaration, public static void main because it is executing, and we'll go. All right. Now let's go ahead and add 3 teams. So kind of like we did before, we're going to instantiate a team object. Right, so this is named exactly like the file that's the class. And I guess we're going to call these team 1, team 2, something like that. Makes sense. Now you could also call them by whatever team name they are. But you can tell I am making this up on the fly. Right. Now inside here, we do have a constructor function. The constructor function takes all 3 values, and that would be, let's see, what would it be? What are the 3 values? High school name, the sport, and the team name, which I think is what they're calling mascot. Okay, so, all right. So we're going to send in, I don't know, how about something like this. And we'll call this team, I don't know, the Dolphins. So that's 1 team. Now we're going to do this again. So we'll make team 2. This will be another new team. But inside here, I'm going to feed in this information. So let's, I don't know, you come up with your own names. Come up with ones that are better than this. How about boys wrestling? And then their mascot can be the Tigers. One more team. And let's do, and I'm going to just say hi. That's fine. This will be about field hockey. There's an obscure one. And we'll call this team, I don't know, how about the Gators? Something like that. 3 teams, 3 high schools, 3 sports, 3 mascots. All right. All right. So now, once again, we get into this issue of like, we want to display this information. And I did tell you that it's a good idea to create a display function inside the class structure, but I'm not going to do that here right now. But I am going to create a display thing, and I'm going to feed into it each team. So I'm going to display team 1, display team 2, etc. This is going to underline red because I don't have this, right? So I'm going to create the method. I'm going to let it propagate automatically. It's set to private static void displayed. That should be just fine. I'm going to change this from team 1 though and just call it team here. And all of this is going to do is put the stuff on the screen, right? So I'm just going to paste this in. And here's my system out print line, right? And I guess last time I called my parameter T, right, to just make the syntax shorter, but it's going to output, it's going to get the name, high school, get the sport. So it'll say boys wrestling team, get the mascot, and then on the next line, our motto is whatever the motto was. And if you remember, the motto was sportsmanship, right, for whatever reason. All right, so there you go. That's our display function. And you know what? If I'm going to display team 1, I need to show also team 2 and team 3. All 3 of them in the mix there. And now I think we're ready to test. So let's do Control S to save. And if this works correctly, we should have an output of all that stuff down here. So here comes the run. All right, so we have Roosevelt High School girls basketball team Dolphins. I'm not sure I like how that reads. We should probably have like B thrown in here, right? Let's do that. I'm gonna look better. All right. Roosevelt High School girls basketball team, the Dolphins. Our motto is sportsmanship. Right? And I mean, if you want to really make this look better, there's so much stuff that you can do to make it look better. I'm just kind of doing it in kind of a primitive fashion, if you will. But you can change the output, make it look better, change the mottos, get all persnickety about it. The real point is that we're able to create the objects as described, set their values, retrieve the values, and put them on the screen. And once again, this is pretty simplistic stuff, but there's a lot of really heavy concepts here that are going on. Once you see how this works, taking these class files and making them significantly more complex and the programs to utilize that complexity, and you unlock a lot of power without writing a lot of code. right? And that's really one of our grand takeaways here. Now I seem to remember that this also had a part B, and it does. And it's saying that we need to create another class file called game. All right, so let's read this. Create a class named game, include 2 team fields that hold data about the teams participating in the game. Also include a field for the game time, for example, 7 p.m. Include a constructor that takes parameters for 2 team objects and a time. Write an application called test game to instantiate it, then pass the game to a method that displays the details about the game. All right, so this is where it gets kind of weird, because if you read this carefully, right, and you might gloss over this as you're reading it, and we got 7 minutes to do this, by the way, so I'm going to do it in hurry up fashion. The thing that we're going to have, the data fields are going to be teams, the class that we created. So this is kind of the ramp up, in the conception here. So follow with me in the few minutes that we have left. All right, I'm going to right click my source folder, create a new class file. I am going to call it game. No public static void main. And I'm going to create the private data fields. I am in hurry up mode, so I'm just putting it out there as I do the video and for the class people. So class people, you might have to watch the video in the aftermath to get this. But I am basically copy pasting most of this, just for speed. So we have 3 private data fields. Notice the data type. It's our own custom type. We really call this a reference type, right? Where we've created this, so it's not like a string or an int or a double again, right? So we'll have 1 team, 2 teams, right? Because you need 2 teams to be in a game, and then you need a time for the game to happen. You will have a constructor function, and then gets for all the fields. I'm going to do this all in one copy paste. So here it is. So here's the constructor. So we are sending in the 2 teams and the time, and then those get stored internally, right? Then we have gets for each one of those, so we can return the information and see it. Right? That's it for the game file. I'm saving it. Right? Next instruction is to create a program called test game to create a game object and pass the game to a method that displays the details about the game. Right? Very specific, but really not that hard to do. So let's do test game. And it will look something like this. Let's right click, new class file, calling it test game. This will have a public static void main. And first, I guess let's begin by creating some team objects. So I'm going to just borrow stuff I did before. So here's 2 teams. Just pasting them in. Team 1, right? Looks familiar, right? Now notice they are playing a game, so they had to be the same kind of sport, right? And 2 different high schools. It couldn't be the same high school and different sports. That wouldn't make any sense. But now we've created 2 team objects. Now we're going to create a game object the same way. So we're going to do game. We'll call that the first game, game 1. We'll create a new game. And then that one will, what are we sending to this? Well, this is expecting to receive team 1, team 2, and a time. So could I just do this? Could I send team 1? Yeah. And then team 2? Yeah, why not? And then the time. And we'll say 7 p.m., just like that, as a string, hard code. So that's sent to a new object. So both of the teams and all their information that goes with the team and all the capabilities of that team that come from this file are now being landing here in the game one, with all those capabilities right here. And this is where it kind of gets a little deep, but think of the power that we're sending really complicated objects now from one spot to another. The next thing that we have to do is display this again. So like we did before, I'm going to write a display method. I'm going to have it auto create it, right? But maybe I should put the data type in here. So what kind of thing am I going to pass? Well, I'm going to throw the whole game in there to display, which carries the teams and all their info too. So it's going to display all the team info, all the game info for both teams, right? And put it on the screen. I am going to use the automatic tool to create this, right? We just need to write the code that goes inside. I don't like the way they name this. I'm just going to call this G, right? And then we're first going to start with, let's prove, right, that we are, okay, so I'm trying to think of like a good way to say this, right, to make this show what we're doing. So I'm going to create actually a couple of complex things inside of this display function, because this is sending the whole game. So this is really hard for me to say very quickly. And I'm looking at the clock going, oh my God, we got 1 minute left. Right. So when I pass a game object, right, and it has both teams embedded in it and the time for the game, and then the teams are embedded in it, and those objects have the name, the mascot, the motto, all that stuff is built in there too. And then I want to use that in output. Well, now I got to reach into the game object and pull back the team information. But in order to do that and then put it on the screen, I have to put it in another team object. So here's how I'm going to do it, right? So I'm going to create 2 temporary team objects, T1, right? And how I'm going to fill that is I'm going to take the game that I'm passing in, and I'm going to get the team information from what? Well, we'll get team 1, right? Because notice there's 2 get statements because there's team 1 and team 2. And then we'll do one more like that, which will be another team object, T2, whose whole purpose is just to grab that information from get team 2, right? So there's that. Now we're going to move to doing our output. So here's my pre-configured output statement. So I'm just going to paste it in. So we're just doing system out print. The game between team 1 gets the name and the sport and the mascot. And then second line. Right. So the game between team 1, the sport and the mascot, and team 2, and get the sport and the mascot. And then finally, the ending message here, which is this, oops, takes place at this time. Right. Right. I know we're out of time, so I'm just going to run this to get it over with. We did move really, really fast on that, and there's probably a whole lot more I'd like to explain, but we just don't have the time. So I'm going to run it, and it says the game between the Roosevelt High School girls basketball Dolphins and Hoover High girls basketball Tigers takes place at 7 p.m. This is a very simplistic output message for really the complexity of what's happening in the background. But what it shows you is we can not only, for example, take a method to call another method, but we can create an object that grabs a different object that we've created, so we can layer these things, right? And the whole object travels with all of its capabilities, all of its information, and then we can really use it to do some real high-level stuff. So in a setup like this now, we can put any teams in here and have it processed correctly, right? Because the setup's correct. All right, folks, that will wrap the video. This is done here.